Hello everyone, this is computer science class. In this lesson, we're going to introduce introduction to algorithm in computer science. By the end of this unity, everyone should be able to identify the appropriate steps to solve a problem, identify an appropriate algorithm for a given problem, and represent graphically algorithm using flowcharts. So to introduce, a computer to work needs a program or a software. So in order to write a program, so you need to follow steps. So before writing any computer program, it is important that a programmer specify the order in which the set of instructions contained in the program are to be executed. This process of defining the step-by-step procedure in which the instructions are going to be executed is what we call algorithm design. The term algorithm was derived from the name of the 9th century Persian mathematician and astronomer Muhammad al-Khwarizmi, and the concept has been adapted in computer science to refer to a step-by-step procedure that specifies how to perform a task or solve a problem. Therefore, a computer program is an algorithm implemented using a programming language. So which means before writing a program, you need first to sit and plan and see how instructions will follow each other. So before writing any program using a programming language, so you have to first define the step-by-step procedures of that program. So to ensure that an algorithm produces the desired solution, the programmer is tasked with the following roles. So each programmer will be doing the following to ensure that the algorithm written is correct or is doing what is supposed to do. One, the programmer has to identify a problem that may be solved using a computer program. So which means before writing a program, you need to know what the program will do. So you need first to identify the problem. After identifying the problem, so you need now to outline the social and technological factors that need to be considered before converting the problem into a computer program. So you have to sit and identify what impact the program will have in the society. What technologies are you going to use so that maybe the program can be accessible to the society? So you don't have to write a program for sake of writing a program. It has to be solving a social problem. So after outlining the social impact, so you need to provide possible solutions to a problem. This may be by means of using off-the-shelf software or custom-made software. So here, before you have the problem, you have identified the problem, you have identified social impact. So now you need to propose or to provide possible solutions so that you will know that the program is doing what it's supposed to do. Otherwise, if after writing a program, you will not know if the program is doing what it's supposed to do. So you need to have possible solution or solutions to a problem. So we have characteristics of an algorithm. So the algorithm should mention correctness. The goal during program design is to produce logical designs. So the design of a system is correct if the system satisfies user's requirements. So the user who will use the program, is he satisfied? So in that case, if the user is satisfied with what the program is doing, so your program or your algorithm is correct. So it is the responsibility of a programmer to find the best possible design within the limitation imposed by the requirement of environment in which the program will be used. So it's up to the programmer to know the user needs and how to satisfy those needs. So an algorithm should be verifiable. Verifiability is concerned with how easily the correctness of the design can be checked. Design should be correct and should be verified for correctness. So you may design an algorithm, but you are not the one to implement. So is the algorithm designed and tested to be corrected, can be verified, can be seen by others as a correct algorithm. Again, the algorithm should be complete or completeness. Completeness requires that designs of different system components be verified. So this requires dry running of the system's data structure, modules, user interface, and module integration. So the program has different parts. So, and each part has to complete one another. So let's say your program is managing a stock. In a stock, there is the inputs of new product, there is output of new product, there is expired product. So those the product that has been entered, they want to be out, they want to be output. So each part has to complete each other. So traceability, in order for a program to meet users' needs and expectation, it is important that the entire design be traceable from user requirement. Another characteristic is efficiency. Good design results in an efficient program that consumes less processor time and memory space. So you have to make your program in such a way it doesn't overload your computer processor. Simplicity, though a program may be complex, its simplicity is one of the most important factors that influences its user-friendliness and ease of maintenance. Even if writing a long program may be complex, but you have to make it simple so that it can be friendly used. So documentation, it is a good practice to provide documentation containing details of the program algorithm. After writing an algorithm, you have to explain, you have to document so that others who want to use it can understand well what you are doing. So the role and the structure of an algorithm. So the role of an algorithm is to support programmers in designing and implementing computer programs that solves a problem of importance. For example, consider a problem of finding the shortest route to travel between Kigali and Musanze. So to solve such a problem, an algorithm design follows a structured approach outlined below. For example, first, the programmer first analyzes the problem to come up with the problem specification. The problem specifications here defines, problem specification define the input, the processing, and the output required to solve the problem. So which means you cannot solve a problem that you did not analyze. And by analyzing this problem, so you provide what we call problem specifications. By problem specifications, you define input, what will be the process, what will be the output, and if you know that, it's easier to solve that problem. After analyzing the problem, you have to map the problem specification into an algorithm that defines the logic and procedure for solving the problem. Then once an algorithm has been designed and tested against problem specifications, so you have to implement it using a suitable programming languages. Then finally the program is installed on a computer or portable devices to solve the problem. So those are the steps on the structures of an algorithm. So here this is the graphical explanation of the problem or the structure of the algorithm. There is a problem, you analyze the problem against the problem specification. After that, you design an algorithm. After having an algorithm tested for correctness, for verifiability and other characteristics, so you write your algorithm using a suitable programming language. Then you compile your program and you install it on computers or portable devices. So now we are going to discuss about design of an algorithm. Design of algorithm. Algorithm can be expressed in many ways, such as using natural languages. You can use pseudocodes, or you can use flowcharts which are used for complex or technical algorithms. So in order to avoid ambiguities common in natural languages statements, most programmers prefer using structured design tools like pseudocodes and flowchart, and we are going to discuss this in the next slide. Number one, we are going to see how to design an algorithm using a natural language. The term natural language refers to the ordinary language like English or Kinyarwanda used by human beings to communicate with each other in speech or in writing. Because an algorithm is a procedure for solving a problem, the natural languages can be used to express the steps to be followed to solve a specific problem. For example, the following is natural language algorithm for how to make a hot sauce. 1. Before you prepare a hot sauce, make sure you have garlic that is peeled and chopped, fresh lime juice, and all the ingredient required to make the hot sauce. After having all the required ingredients, so now and materials, then you are going to combine pepper, garlic, lime juice, vinegar, mustard, oil, and all that can be combined in a blender, and you pour until smooth. Collect the seasoning, adding more salt or molasses to taste. Then after all of those, you transfer the sauce to the clean bottle. You can serve it right away, but the flavor improves if you let it age for a few days. So this is how you can make or how you can prepare a hot sauce. So this is a natural language. As you can see, you speak it in the language that you speak. The above algorithm is a recipe, that is a step-by-step instruction that takes low ingredients and procedures to test the product, which is hot sauce. However, one of the limitations of such an algorithm is that it tends to be verbose or ambiguous. Furthermore, there are different languages in the world, which makes it difficult for an algorithm written in particular language to be universal. To avoid ambiguities innate in natural languages, there are languages-independent tools such as pseudocode and flowcharts to be discussed later in this section. So with natural language, you may express the algorithm in English, yet the one to implement this algorithm doesn't understand the English. So in that case, some words can be interpreted in different way as the algorithm designer has interpreted. So in that case, it may cause some errors in the algorithm or in the program. So now here there is an activity where the user is required to write a step-by-step of this problem. Consider a payroll program used to compute employees' salary based on the basic salary, house allowance, commute and overtime allowance. So the basic salary is based on 8 hours per pay for 5 days a week. If monthly net salary is less than 15%, pay as you earn. And if 2% medical cover, perform the following tasks. So using natural language such as English, you need to develop an algorithm for the program that calculates gross salary and net and total deduction. So with this algorithm, this problem, you need to first identify what are the inputs. So the input here will be the basic salary. Then from the basic salary, you calculate basing on the instructions. Then after the process will be multiplication, the process will be deduction. Then after you calculate the gross salary and the net salary and the total deduction. So you can do this exercise as you are revising. Now we are going to discuss how to design an algorithm using pseudocode. Pseudocode is a standard method of describing an algorithm without use of any specific programming language. So the word pseudo means that although pseudocode statements resemble a real program code, it cannot be executed by the computer. So the purpose of the pseudocode design is to help the programmers formulate their thoughts on the organization and the sequence of the computer algorithm without the need of the following the actual coding syntax. So with the pseudocode, the code you write is not a natural language, is not a computer language, so it's in between, and here it follows some rules. So although pseudocode is frequently used, there are no standards for its implementation. In most cases, we borrow keywords such as print, write, input, and read from programming languages like Fortran and Pascal to express an algorithm as a pseudocode. So the pseudocode has some key terms it uses. For example, when you need to print to display something, we use the keyword print. You can use the keyword write to display. You can use the keyword input to show that the data is being input from the user input. Read is the same as input. So the pseudocode has some key terms it uses to write the pseudocode. And For example, here we have this example, which is a pseudocode to calculate and display the area of circle. So here we can see we have some keywords. We have the word begin. So this begin shows where the pseudocode begins, and here we have the keyword set. We have the keyword set, which set the value of 3.142 to pi, and this value is known. Then here we have another instruction saying write enter radius of a circle. What that means? Write means display or output, and the message here meaning enter radius of a circle. As you can see, this message or this text is within the quotation mark. So this means the text or the value within the quotation mark is going to be displayed the same way it is written. So which means this instruction, this line tells the user what to do. It tells the user to enter the radius of the circle. Then here the keyword read means input, enter. So it tells the user to supply the value of the radius, and the value of the radius will be stored in the memory called radius. Then after here we are going to calculate the area. So the area will be equal to pi, which is 3.4142 times radius. So the value of radius has been supplied by the user here. Then this will assign will assign the value of area in an area. Then we say write area. So here we are displaying the value of area, which is stored in this location called area. Then we say end to mean that the pseudocode ends from there. So basically this pseudocode or this algorithm will initialize or will store the value of pi in a variable or in a space called pi. Then it will ask the user to enter or to supply the value of radius. The value will be entered by the user. Then the process will be to calculate the area by taking radius times pi. Then we display the area which has been calculated, and we end the pseudocode or the algorithm. In the next slide, we are going to see what you have to consider when writing the pseudocode. So to avoid ambiguities experienced with the use of natural languages, the following basic rules to be followed when writing a pseudocode. Number 1, pseudocode statement should be short, clear, and readable. Yeah, it's obvious. You have to make sure your pseudocode is short, it's clear, and it can be read in an easy way. The statements must not have more than one meaning, which means should avoid any kind of ambiguity. So you have to make sure that the statement you are writing or each instruction you are writing has a unique meaning so that it cannot confuse the programmer or anyone who is going to read your pseudocode. So the pseudocode again, the pseudocode lines should be clearly outlined and identified clearly. A pseudocode should show clearly the start and the stop of executable statement. So you have to mention the beginning and the end of your statements. Input, output, and processing statements should be clearly stated using these keywords such as print, read, input, and this will show that you are entering or you are inputting, you are processing, or you are outputting. Some advantages of using pseudocodes. So the following are some advantages of using pseudocodes to express an algorithm. 1. Pseudocode is easy to use and create because it uses English-like statements. So you use your English-like keywords so that you can write the pseudocode, and that will make pseudocode be easier and to use and be easier to create. Pseudocode requires very little syntax to write. So just it's input, output, or read, write, and you initialize values to variables, and that is all about pseudocode. So it uses very little syntaxes. Statements of a pseudocode can easily be translated to any high-level language. So when your pseudocode is well organized, well written, so to convert it to a programming language is very easier. Pseudocode reduces time spent in coding, testing, and modifying a system. So when you have written your pseudocode, it's just to like copying from pseudocode to programming language. So you don't need to modify you don't need to write new instructions. So you just implement what you have written in pseudocode and you put it in a programming language. So pseudocode implements structured concept in a better way. So here there is an assignment, 3 questions that you need to work out and make sure you do them well. So in the next lesson, we are going to discuss the design of an algorithm using flowcharts. May you have any question? Feel free to email me at codesingb@academy.org, or you can send me a text on WhatsApp on that number. Thank you.